Hello geometry students, here's your lesson for section 4.7, Triangle Congruence, CPCTC with Missy McCarthy, math instructor at Okemos High School. By the end of this lesson, you should be able to say that I can use CPCTC and know that it stands for corresponding parts of congruent triangles are congruent. You should also be able to say, I can use CPCTC in conjunction with other triangle congruence postulates and theorems to prove that parts of triangles are congruent, and I can use CPCTC to find missing values for x. So CPCTC is actually short for, I don't even know why they do this. It actually just is another way of using the definition of congruent polygons or definition of congruent triangles, which says two triangles are congruent if and only if all of their corresponding parts are congruent. So they made up this acronym CPCTC that stands for corresponding parts of congruent triangles are congruent. Okay, so we're going to use that as a justification in our proofs to say that individual parts are congruent after we have first proven that the triangles are congruent. So here's a short example of how you would use CPCTC. So I'm looking at this figure here, and I also realize that, that these two triangles, triangle PSR and triangle QSR, have that side in common, and they also have some congruent angles. So a really short example, I could say that angle PRS is congruent to angle QRS. That was given to us. We also know that angle P is congruent to angle Q. That was given to us. And then we could also say that RS is congruent to RS by the reflexive property, which makes these two triangles, triangle PRS, congruent to triangle QRS by angle, side. Okay, so that's why those two triangles are congruent. Now, how do then I take that and use CPCTC? As a result of proving those two triangles are congruent, I can now say that any other additional parts of the triangle are also congruent. So I can draw the conclusion that PS is congruent to SQ by CPCTC because they are corresponding parts of congruent triangles, so they must be congruent. I could also say that this angle is congruent to this angle by CPCTC. And I could say that this side is congruent to this side by CPCTC. So we can say additional things are congruent after we've proven that the triangles are congruent using corresponding parts of congruent triangles are congruent. All right, so for this example, we know that A and B are on the edges of a ravine, and we need to find the length of AB. So if I can first show that the triangles are congruent, then I could use that to find the length of AB along the edge of this ravine. So I believe that it's telling us that this length right here is 15, and we also know that this length right here is 15. So we have two pairs of congruent sides in these two triangles. I also know that this side right here is 10 and this side right here is 10. So we have two other congruent parts. We also know that these angles are congruent because they are vertical angles. So I have just proven that the triangles are congruent by side angle side congruence. Side angle side, side angle side. So because the triangles are congruent, I know now, I'm going to do the new parts that I know in purple. I know that this side is equal to or congruent to that side. So that means segment AB must be 18 miles. And I know that by corresponding parts of congruent triangles are congruent, or because corresponding parts of congruent triangles are congruent. All right, so what are you going to be doing with the CPCTC? Mostly, you're going to be using it to do proofs. First, prove that the triangles are congruent, and then after you know that the triangles are congruent, prove that, in this case, angle XYW is congruent to angle ZYW. So our first task is to prove that the triangles are congruent. So we're going to be using one of those triangle congruence postulates or theorems that we already have. Oops, I put theorems there and it should be statements and reasons. All right, so let's see if we can walk through this. They first tell us that segment YW bisects segment XZ. So segment YW, that's this guy right here, bisects this segment XZ. So it's not bisecting an angle, it's bisecting a segment, which means that W is the midpoint. So if it bisects it, that means that that is congruent to that. So step 2 would be, we know that XW is congruent to WZ by definition of bisector, or definition of bisects. All right, so that's the first thing we have. Now what else do we have? The second given statement is that XY is congruent to YZ. That is given to us. So XY is congruent to YZ. Good. So I don't have any information on any angles, so I'm going to try to prove that these two triangles are congruent by side, side, side. And I know, lastly, that WY or YW is congruent to itself. YW is in both of those triangles, and it's congruent to itself by the reflexive property of congruence. All right, so we have that. Now we can say that the two triangles are congruent. That means that triangle XWY is congruent to triangle ZWY by side, side, side triangle congruence. Therefore, we can say that angle XYW is congruent to angle ZYW by CPCTC. And XYW is this angle right here, and ZYW is this angle right here, and they are congruent because corresponding parts of congruent triangles are congruent. So with all of these proofs, this part you will have been practicing already, how to prove that triangles congruent. So first, prove triangles congruent. And then use CPCTC to prove that parts are congruent. All right, here's our last one. We are going to do another triangle congruence proof. So our statements and reasons are going to go here. Statements and reasons. And as soon as I see these givens here that things are parallel, I'm thinking our parallel lines cut by a transversal. Most of the time they're going to give you alternate interior angles, but sometimes corresponding angles are congruent. So 1, NO is parallel to MP. That is given. So let's see what our transversal might be. NO is parallel to MP. That makes this guy the transversal. Okay? And that's going to give us some congruent angles. That angle is congruent to that one. So we've got angle NOM is congruent to angle PMO, and that is because they are alternate interior angles. So alternate interior angles theorem. Two parallel lines cut by a transversal, alternate interior angles are congruent. All right, so that's the first thing we've got. I'm going to erase those except for my angle marks. Then they tell us that angle N is congruent to angle P. Angle N is congruent to angle P. All right, that is given to us. So we've got two pair angles, so it's either angle side angle or angle angle side. I don't have any other given statements, but I do know that MO is in both of the triangles and it is congruent to itself. MO is congruent to MO, and that is by the reflexive property of congruence. Alrighty, so that means that these two triangles are congruent. Triangle MNO is congruent to triangle, what goes with M? It would be OPM. OPM, no, yep. And that is by angle, angle, side congruence. Angle, angle, side, angle, angle, side. So then that means, ooh, if that's true, notice right here for what I'm trying to prove, I'm not trying to prove that any parts are congruent. I'm trying to prove that these two are parallel to each other. So now that I have those congruent, I can say, I'm trying to prove that these are parallel. That's what I'm trying to prove. Oh, what if I said that this angle right here was congruent to that angle? Nope. Transversal, this angle and this angle. That's what I want. So I want to say that angle NMO is congruent to angle POM, and that is by CPCTC. But notice, those are alternate interior angles. If MO is your transversal and M and N are your parallel lines, so that means now that MN is parallel to OP by the converse of the alternate interior angles theorem. So that one had one more step. First, we had to prove that triangles were congruent. Then we had to use CPCTC, and then after that, we had to say that they were parallel by the converse of the alternate interior angles theorem. All right, so more practice in class with these I can statements. Can you use CPCTC and know what it stands for? Can you use it to prove, in conjunction with triangle congruence postulates and theorems? And can you use it to find missing values for X? See you in class.